Okay, so the next lesson is on something called permutations involving similar objects. Okay, so we'll just jump straight into the first example, and this example actually is it should be a bit of a review. It has actually nothing to do with similar objects quite yet. What I do with the second example is I implement this concept of similar objects with the second one, but I'd like to use the first one as an example. All right, so just for review. Okay, so how many arrangements can be made from the letters in the word bed? Okay, so in other words, we have 3 spaces, and we have 3 options for the first one. So this is just using like a fundamental counting principle. 2 options for the second one, and 1 for the third. So if we multiply that together, 3 times 2 times 1, which is 6. All right, so there's 6 arrangements. Or we can use what we did last lesson with permutations. So this would be equivalent to, if we want to interpret it as a permutation question, this would be 3 pick 3. Okay, so we have 3 options, and we're actually picking 3 letters. Okay, so 3 pick 3. Now the formula for permutations, I'll just scroll up here, is not n pick r, is n factorial over n minus r factorial. Okay, so in this case, this will be 3 factorial over 3 minus 3 factorial, which is the same as 3 factorial over 3, 0 factorial. And 0 factorial is actually 1. Okay, so it's 3 factorial over 1. Oops. Just erase that. 3 factorial over 1, which is 3 factorials again 6 over 1, which is just 6. Okay, so you can interpret this as a permutations question as well. All right, so this first method here was the fundamental counting principle. The second one's permutation. All right, by definition. Now the other thing is you should have a n pick r button on your calculator. So you would just punch in 3 and hit that function and 3 again, and it should give you 6. All right. Now, to explain the concept of similar objects, what I'm going to do here is actually just, in this first example, just list off all 6 possibilities for the letters in bed. All right. So we have B, E, D. Then we can arrange it B, D, E. Then we can go E, B, D, E, D, B, and then what's that one? D, B, E, D. No, sorry, that's a D. D, E, B. Okay, so these are the 6 possibilities, or permutations that we can come from using all 3 letters in the word bed. Okay, so these are the 6 possible arrangements. The letters are all in different orders. Okay. Now, if I scroll to the next example, what you see it's asking is how many arrangements can be made from the letters in the word B, E, E, or B. All right. So what you'll notice here is that basically what's happened is we replace the D with an E, and I have 2 E's now. All right. So if I go back to this list here, if I switch all the D's to E's, what you'll notice here is that here I got BEE, BEE. These are actually the same, right? So maybe I'll circle these 2, right? Here I got ED, EBE, and EBE. So these 2 are the same. And likewise, EEB, EEB, these are the same. So instead of having 6, we will actually only have just 3 arrangements. Since the D, the E is being repeated, right? So instead of having bed, we have BE. Right? So you can see here visually. Maybe I'll, you know what? Maybe I'll just write that out. We can only have BEE, EBE, then EEB. Okay, so there's no other possibilities. All right, now mathematically, this is a very simple, it's only 3 letters and so on. So this is a very kind of a small example, but there will be times where we come across a bigger word like the next example. All right, so Mississippi. We're not going to arrange all the different arrangements for that. This is just to kind of visually show what the question's asking. All right, so these would be the 3 different arrangements. Now, mathematically, to figure this out, what we do is we use this kind of concept where we take the total number of letters, okay, which is 3, and then we have 2, or put in quotation marks, e's. All right, so therefore the answer is going to be the 3 factorial, so the total 3 factorial, and then we're going to divide it by 2 factorial. Okay, so this would be 3 factorial, which is 3 times 2 times 1, over 2 factorial, which is 2 times 1. This is 6 over 2, which is 3. Okay, so there's only 3 arrangements in this case. All right, so again, you take the total number of letters, or total number of items, and divide it by the repeating letters, the factorials. All right, so this will be easier to kind of visually see once we do this third example. All right, so this word here is Mississippi. All right, so you notice there's a lot of, we want to know how many ways we can arrange the letters in this word. There's, let's see, how many total letters? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there's 11 total. And what I'm going to do now is I'm going to list off the repeating letters. So I have 1, 2, 3, 4 I's. I have 4 S's. And I also have 2 P's. All right. And then 1 M. All right. So, but the M, it doesn't repeat, so we're not worried about that. So to get the answer to this, basically we're going to take the total number of letters, and then we're going to divide it by each one of these factorials. So 4 factorial, 4 factorial, and 2 factorials. Right? So anything that repeats, we're going to divide by that factorial. And so this, therefore, is going to equal, and we'll just pull the calculator up, 11 factorial. Okay, so 39 million. All right, 39 million. 116,800. And then I'm going to have to divide it by 4 factorial, which is, I think I have that one memorized. 4 times 3 times 2 is 24. So 24 times 24 times 2. Okay, so the other thing is, yeah, when I'm going to punch this into my calculator right now. When I divide it, so I'm going to take this 11 factorial, divide it. I'm going to make sure that the denominator here, I'm going to actually put it into brackets. All right, so I'm going to punch in 24 times 24 times 2. And that's going to give me, so that's 1152 on the bottom, or 1152 on the bottom. Actually, you know what? I'm going to write that in between here. So 39,916, 800, 1125. Sorry, 2552. 52. Okay. So the answer to this would be 34,650. Okay. So yeah, if you're going to just go from, I just want to point that out. If you're going to go from this step straight to here, make sure you put this in brackets. Okay. Or you can just work the denominator out and then divide it as well. You should get the same answer. Right. If you don't put this in brackets, basically what it's going to do is it's going to take the top here, and then it's going to divide by the 24, and then it will multiply itself by 24 and 2. So in other words, the 24 and 2 would be placed up top if you don't put it in brackets. All right, so make sure that's pretty key to put that in brackets when you're dividing by the denominator. Cool. All right. So that's basically the concept of similar objects. Now, what you'll find in the worksheet is that there's some kind of like, I guess we'd go like review type questions from the previous two, but a little bit more complicated type questions. So I thought I'd include a couple of those examples as well in this video. All right. So this next example, theoretically, you should be able to answer this before this lesson. But anyways, it's a good idea to review this stuff. This permutation stuff can get quite confusing, quite complicated. So, but the best way to learn this is through practice. All right. So how many arrangements of the word zebra are there if there are no restrictions? Okay. So there are 5 letters. So what I prefer to do, what I like to do, is use the fundamental counting principle, where I put when I write out the number of spots, and then just fill in the number of possibilities, and then multiply them together. Okay, so this 5 letters, you use all 5, so that would be 5 factorial, or 5 times 4 times 3 times 2, which is 20 times 6, 120. Okay. Now the next one here, the first letter must be an R. Okay, so then I got these 5 spots. However, this first letter must be an R, so we only have one option there. And then we have the other 4. Okay, so 4 there, 3 there, 2, and the 1 there. So if I was to multiply that together, that's going to equal 24. Okay, so in other words, if the first letter is an R, basically what you're doing is you're trying to figure out the number of ways to arrange the other 4 letters. All right, so that would be 4 times 3 times 2 times 4. All right, next up, the first letter must not be an R. All right, so this is where this is probably something new, actually. Just something about it. So in this case, what we want to do is we want to take the total possible arrangements. All right, so total number of possible arrangements. And then if I have that total possible number of arrangements, and I subtract the arrangements that start with an A, or start with an R. Sorry, this is taking longer to write out than I thought it was. So if you think about it, right, if I take the total number of possible arrangements with no restrictions, so there's 120 of them, the zebra, and I subtract the ones that start with an R, what's left over should be the ones that don't start with an R. Okay, so whenever you spot the word not in one of these types of questions, you will always be doing like a total, and the total possible ways, and then minus the ones that satisfy the restriction. That will give you the opposite number, right? So in this case, you're going to take 120. So that's the total number of possible arrangements. And from here, I'm going to subtract the 24 arrangements that they actually does start with an R. And then what's left over should be the number of arrangements without an R that don't start with an R. Okay, so 120 minus 24, which is 96. Okay. Cool. All right, so let's go to the next one here. Now that I'm scrolling down, I'm just going to write the word zebra here on the side, just as a reference. Okay, so first letter must be an R, last letter must be a Z. Okay, so I have the 5 spots. First letter must be an R. Okay, so this would only have one option. And the last letter must be a Z, so I only have one option there. So now I got 3 left over here, 2, and then 1. Okay, so in this case, when I multiply these together, there's only 6 ways, right? If the first letter is an R and last letter is Z. Okay. Next up, arrangements must begin with and end with a vowel. Okay, so again, 5 spots. How many vowels are there? There are 2 vowels. Right? So there's 2 possibilities at the front. Right? I can use the E or the A. And there's only one possibility at the end because I've already used one of the vowels. Right? So there's 2 options there for a vowel, 1 option that's left over. And then the other 3 letters, I have 3 options here, 2 options there, and 1 option there. Okay, so if I multiply these together, it's going to equal 12. Okay, next up, the Z and E must be together. Okay. So when it comes to this here, let me just write zebra up again. Whenever you have two things that must always be together, what you want to do is you want to actually consider them as like one letter or one block. All right. So instead of organizing 4 or 5 letters, what we're actually doing is we're organizing 4. All right. So the reason for that is the Z and the E are considered to be like one of those letters, just a letter. Okay. So consider Z, E, maybe I'll put a box around that, to be one letter. So in other words, instead of arranging 5 letters, we're actually arranging 4 objects. I'll say objects instead of letters. All right. So in other words, we can have, we're going to go Z, the B, the R, the A. Oh, sorry. So yeah, B, R, A, bra. All right. And then we're going to consider the Z, E as one letter. Okay, so there would be 4 options here, 3 options there, 2 options there, and 1 option. Now, this is actually one more adjustment we need to do, is we need to multiply this by 2. All right. The reason we're multiplying it by 2 is because there are 2 ways of arranging the Z and the E. Right? You can have ZE, or you can have EZ. Okay, so these 2 would be flip-flopped, right? So there's 2 possibilities within, I guess this could be considered one letter. There are 2 different ways of combining the Z and the E, okay? The ZE and EZ. So that's why once we arrange the 4 objects, we must multiply it by 2 because there's 2 different ways of arranging the ZE. All right. So therefore, this is going to equal. If I multiply that together, that's 12 times 2 is 24 times 2 is 48. Okay. All right, and the last one here, the Z and E must never be together. Okay, so again, we have again, not or never condition. So we're going to just take the total and then minus when the Z and E are together. Right? So total minus ZE together. All right, so the total number of ways was 120. Yep. So the total possible number of ways with no restrictions is 120. From there, I'm going to subtract the number of ways of putting the Z and E together, which is 48. So therefore, that is going to be 72 ways. Okay. So again, whenever you spot the word never or not together, a not statement, take the total minus the times that it is happening. Okay, cool. Now there is actually one more example that I'm going to go through. Okay, so this example here is similar to the last question in the worksheet. All I did is actually I just copied and pasted, but I just changed the numbers around, all right, just to illustrate it. So you saw that question to practice with. So this here, all right, let's just we have 5 English books, 7 science books, and 4 math books to put on a shelf. All right. So how many arrangements can the books? How many ways, different ways, can the books be arranged if all the science books, all the English books, science books, and math books are the same? Okay, so now we're actually dealing with identical objects, right? So these 5 English books are exactly the same. 7 English books or 7 science books. Can't read today, and 4 math books. Okay, so this is similar to going back to like the first couple examples where kind of like that Mississippi example. Okay, so total books. Is going to be 5 plus 7 plus 4, which is 16. Okay, so to answer this question, I would have 16 books. So 16 total ways of arranging. However, I have 5 exactly same English books. So they're all identical. So I'm going to divide by 5 factorial. 7 science books, so divide by 7 factorial, as well divide by 4 factorial. Okay, so the 4 math books. All right, so this one here. Okay, so let's punch in 16 factorial. It's going to be a huge number. Oh boy. Yeah, so actually, you know what? Let's just do it all at once. So this is 16 factorial. So I'm going to divide it by bracket 5 factorial times 7 factorial times 4 factorial. And then I'm going to close the bracket. And so this should be the denominator and equals. All right, so there's going to be 1,441,440 ways. Okay, so again, these books are all identical. Okay. Next up, how many different ways can the books be arranged if all the English books, science books, and math books are different? Okay, so they're all different books, but the English books, science books, and math books must be together and on the shelf. All right, so what it's saying is like you'll have all the English books here, then you'll have all the science books here, you'll have all the math books here. All right? Or these can be different orders too, right? So I got science there, English there, math here, right, and so on. All right, so you can kind of visually see that the first thing we want to do is just figure out how many ways can we order these 3 subjects. Okay, so so there are going to be basically there's 3 subjects, right? So there's going to be 3 factorial ways of ordering the subjects. Okay. So again, 3 factorial because again I have the 3 subjects, right? So like 3 spots. I have 3 options for the first, like whichever subject can go first, 2, then in the 1. Right? So that's going to be 3 factorial, which is 6. Okay. All right. Now to answer this question, again, we're going to take the 3 factorial, but then what we need to do is we need to multiply it by how many ways you can arrange the English books, right? Times how many ways you can arrange the science books, times how many ways you can arrange the math books. Okay, so just the numbers were 5 English, 7 math, 7 science, 4 math. Actually, they're right here, so I can kind of cheat. Okay, so 5 factorial, 7 factorial, and 4 factorial. Okay, so this is going to be the answer. Okay, so again, this has to do with the ways to order the subjects. And this one here would be the English books. This would be science. And this would be math. Okay, so we got to multiply these individual subject factorials because all these English books are different, right? So there's 5 factorial ways of arranging those English books. Likewise, 7 factorial ways of arranging the science books, 4 factorial ways of arranging the math books. And overall, there's 3 subjects. Okay, so let's multiply that together. All right, so I'm going to go, let's clear that. 3 factorial times 5 factorial times 7 factorial times 4 factorial. All right, so 87 million. That's going to equal 87,091,200 ways. All right. Let me just fix that right there. That should be a 0. All right. So yeah. So this one's kind of tricky. Just the individual subjects, like the books within them, and then just the overall different ways of arranging those subjects. You multiply it by that. All right, this last one. How many different ways can the books be arranged in all English books, science books, and math books are the same? Okay, so they're all the same. And the English books, science books, and math books must be together on the shelf. Okay, this is quite wordy. So basically what it's saying is that all the books for each subject are the same. All right, so if you imagine, if I just have the English books, since they're all the same, it doesn't matter which way or within them, right? Because it's just going to be one block of English books that are exactly the same. Same with the science books, same with the math books. All right, so therefore, the answer to this would be 3 factorial, because we're only worried about how we can arrange these overall subjects. All right, but within the subjects, since all the books are the same, it doesn't matter. It doesn't matter how many ways we can arrange them, because there's only going to be one way. All right, so technically, if I wanted to kind of write this out, similar like a similar template to this one here, it's going to be 3 factorial, but then it's going to be like 1 times 1 times 1. Okay, because there's only one way of arranging the identical books within each subject. All right, so this is 3 factorial, which is 6. All right. Cool. So that is the lesson on similar objects. I'm just going to open up the practice worksheet. Okay, so for this worksheet, so I made a little bit of adjustment here. Just do the circle questions that are in red. Maybe I'll run this down with you right now. So numbers 1, 2, 3. Actually, the first 3 have to do with the similar objects. All right, so you take the whole number of letters and then divide it by the number of repeating letters, factorials. Right? Number 4, this is kind of review where it's always together, not together. So you can use the fundamental counter principle for that. I didn't do an example of this today, but for number 7 and 8, for these questions here, I did an example. I think it was in the first. Let me just check that. I'll just show you where these 7 and 8, they're similar to. I'll just open the 3.1 here. So check, they're similar to this one here, example 4 from the 3.1 lesson. All right, so if you need a little refresher, you can watch the 3.1 lesson. It's the 4th example, right, where I split it up into cases. That's what we're going to need to do for 7 and 8. Okay, so that's why it says use cases. How many 3-letter arrangements can be made from the word keyboard? Okay, so we're picking 3 out of the keywords. This is from the last lesson, 3.2. Actually, I can just verbally tell you right now. It would just be 1, 2, 3, 4, 5, 6, 7. So there's 8 total letters, right? And we're picking 3. So 8 pick 3 would be the answer for this one. Okay. Number 13, I did an example of that today in that lesson. 14, 15, 16. These are also permutation questions from the last video. Okay, so that's fairly straightforward. You just actually these are fairly quick. Right? You have 10 options, 10 candidates. You have 3 positions, so this would be 10 pick 3. It's that simple. 60 pick 3 for 15. Right, 60 options, picking 3 numbers from the block, and so on. Right, and number 17 here is the last example that I went through today with the books on the shelf. All right. Cool, guys. So that's the lesson for today. Hope you guys are doing well. And I'll meet up with you guys later. All right. Ciao.